In this lesson, we're going to introduce you to a networking term called the topology. Now, what is a topology? A topology is really just a graphical depiction of the layout of the computer network. In this one, we're going to talk about two different types of topologies called the physical and the logical topologies. Now, this is going to seem a little bit weird at first, but after we go through it, I think you'll understand. And it's critical because you're going to find later on that different types of networking standards may use one type of physical topology, but use an entirely different logical topology. Let's first take a look at the physical topology. The physical topology simply refers to the way the computer network is wired, the way it is physically wired. So in this example, let's say we have some hosts here, and this is how they connect physically to the computer network. Now, there might be different ways. You might have a different type of computer network that connects the host in a very different physical manner. In this example, we have a network medium right here, and each host connects to that network medium through a wire. Physically, if you were to look at the computer network, that's kind of what it would look like. Now, in this example, the physical topology is different. This host is connected to this host, and then this host is connected again to this host, and this host is connected to this host. This one has kind of a flat bus type of topology. This one has more of a ring type of topology. Okay, again, the physical topology is the way that the computer network is physically wired. By way of analogy, I had a coworker who explained this to me years and years and years ago, and it made total sense. In his analogy, he said that the physical topology is kind of like the roads in the town where you live. Okay? It's the physical roads. There's a road that goes this way, there's a road that goes this way. If we were to look down here at a map, we'd say, okay, this is Main Street, this is Center Street, and the street I live on comes down here like this. You have to take a left, and there's my house. Okay? That is the physical topology of the roads inside your town. Very similar to the way that the computer network is wired. The physical way the computer network is wired may not actually be the way the computer network works logically. Let's go back to our map analogy. In this map, we said this here is Center Street, this is Main Street, and this street is the street I live on. Physical topology. The logical topology, however, is the rules of the road that govern how traffic flows. Okay? So this street might be a one-way street. Even though it's built such that it looks like, well, traffic could theoretically go both ways. According to the physical topology, according to the logical topology, traffic can only travel in one direction. There might be a stop sign right here. It says you have to stop. Again, the physical topology does not prevent traffic from going through. There's no roadblock there that stops traffic from going along that road. Instead, what we have is just a stop sign that says, please stop here. Look both ways before proceeding. Okay? Again, the logical topology is kind of like the rules of the road that govern how the traffic works. Let's move over here to our computer networks. Our logical topology describes how data may flow on these networks. You may have a network that's wired like this, but operate in a completely different manner. For example, let's say we have a network that's wired like this. All the hosts connect to a central connecting point. That's the physical topology. However, the way the protocols and the way the hardware is programmed to work, it may actually operate logically using this type of topology. It's physically wired like a star, but it operates logically like a ring. Let's first take a look at the bus topology. Now, the bus topology has been with us a long time. Many of the networking standards that we're going to work with will use the bus topology, whether physically or logically, it's still with us. Let's take a look at what the bus topology looks like. Now, with the bus topology, all the data flows on this central wire. Each and every host connected to that wire can communicate directly with any other host connected to the wire. For instance, host A here can communicate directly with host B and vice versa. Now, you probably won't see a lot of networks that still use the physical bus topology anymore. However, you will find many networks that still operate logically as a bus. That's why it's important that you understand it, not just for your Network Plus test, but because you need to understand how the bus topology works in order to work with most of the modern network communicating standards. Let's take a look at the ring topology. In the ring network topology, there is no central connecting medium. Instead, you have point-to-point connections between network hosts. In other words, host A here is connected to host B, and it's connected to host D. Host B is connected to host C and to host A. Host C is connected to host D and host B. Unlike the bus topology, with a ring topology, a given workstation or host, such as C right here, can only communicate with two other hosts on the network. Directly, that is. It can only communicate directly with host B, or it can only communicate directly with host D. You're thinking, well, what if I need to get information from C to A? What happens is C sends its information across this part of the network to B. Then B takes a look at the information and says, oh, that's not for me. I'll forward it on. A gets a hold of the message and says, hey, that message is addressed to me, and it accepts the information. So in this way, information can be passed to any host on the network. It may not be a direct connection, as we pointed out. It may have to go from host to host to host before it eventually arrives at its destination. You probably won't work with a lot of ring topologies anymore. The standards that used ring topologies have kind of fallen by the wayside. There's still a large installed base. You'll probably run into it, hence why you still have to learn it for your Network Plus. But be aware that it's kind of a falling out networking technology. Now, a star topology is very different from a ring or a bus topology. It uses what's called a central connecting device. All the hosts on the network connect to this central connecting device with a network cable. Now, if I have a host A over here, and it needs to send information to a host C, what it does is it sends the information to the central connecting device. The central connecting device then replicates the information and forwards it on to the appropriate host. Now, the way that happens and how this central connecting device works depends on the networking standard that you're using. With some devices, it may actually take a copy of that information and send it out to all the hosts, even the originator that are connected to the network. And the way it works is that each host looks at the information and says, who's this addressed to? If it's addressed to host C, then when hosts A and B receive that information, they say, oh, that's not for me, and they'll drop it. Now, not all networking technologies actually work that way. Some of them will operate in a very different manner. Some will, the central connecting device will take a look at the network and say, okay, host C is connected down here, host B is connected over here, and host A is connected over here. So when host A sends information to the central connecting point that's addressed to C, the central connecting device will take a look and say, okay, host C is connected right here, and it will only send the information to host C. You really need to understand the star topology and how it works, because most of the computer networks you're going to be working with as a network administrator will use the star physical topology. Probably one of the most popular, most widely implemented technologies around. But remember, all networks can operate on two levels. They may have a physical topology that's very different from the logical topology. Understand that most of the networks implemented today use the physical star topology. However, how it works logically could be very different. It may still use a logical bus, or it could even use a logical ring topology. Let's take a look at the mesh networking topology. Now, the mesh networking topology used to be kind of an odd bird. It was theoretical, basically. because nobody actually did it. We'll go through this and you'll kind of see why. Using the mesh networking topology, if you had 4 hosts on your network, you would establish a point-to-point connection between each and every host. As you can see, this starts getting really ugly fast. With 4 hosts, it's not too bad. Imagine what this network would look like if you had, say, 100 hosts. There'd be so many point-to-point connections, you would not be able to keep track of all of them. Now, as I said, 10 years ago, the mesh topology was pretty much theoretical. That's because in order to implement it, you would have to install a separate network interface in every machine for every other machine, which means if you had 20 hosts on your network, you'd have to install 20 different network interfaces in every single host to establish the point-to-point connection between the hosts. You know, doing that in the real world was not even really a feasible thing to do. That's all changed, however. With the advent of wireless networking technology, however, this type of networking topology can actually be implemented with a degree of feasibility. Let's take a look. In this network, if this were a wired network, we'd have to install 3 network interfaces in every host. And each network interface would have a dedicated line to every other host. With a wireless technology, however, these wires go away, and what you have is a radio signal instead. Now, because of the fact that you can implement radio signals very easily, you can actually create a mesh network. That's because each wireless transmitter can directly communicate with the wireless receiver on any other host in the network. Now, most wireless networks are not actually set up this way. Most of them are actually configured more of us in a star topology, where there's a central connecting point called a wireless access point to which all the transmitters of the hosts connect to. However, there is a different type of wireless network that you have the option of setting up. It's called an ad hoc wireless network. In this network, there is no central connecting point. Instead, every wireless host communicates directly with any other wireless host. You can see that instead of having a star topology, if you do it with the ad hoc network, you have a true mesh topology. Now, ad hoc networks are not usually implemented very frequently because it's kind of like a peer-to-peer network. If you have 5 or 6 hosts, it works pretty well. If you get more than about 10, the amount of work to set up, configure, maintain it is not worth it, and most folks go to a typical star topology using a central connecting point. So, there are 2 different types of topology categories. There's the physical and the logical topology. The physical topology describes the physical way the network's wired. Logical topology describes the way the network actually operates.